slide is not changing. Okay, now it's okay. How to give it in slideshow?
Yes, sir.
Clicking slideshow.
Yes,
Sir,
first
I have tried it and it
Okay.
came to the platform. I have tried it.
Okay, now it's okay.
Yes.
Okay. So now this optimization, generally an optimization problem in mathematics, how we design. So this is our optimization problem, minimize some functions. This is called objective functions. X is design variables. X does not mean that this is only one variable. X means x1, x2, xn. So design variables. So I am taking a minimization problem. This may be a maximization problem. Also maximize f naught x subject to some constraints. So here gix less than equal to bi. So there may be gix. So there may be inequality constant. There may be equality constraints. So there may be say m number here I equal to m number of constant and some non-negativity or a range of the variables generally given. So there will be some say xi between li less than xi less than ui like this. So here f naught, the objective function, is a function from Rn to R, because we will get a simple value of the minimization problem or maximization problem where x at the is a vector of design variables. So ultimately there will be n number of variables which we call design variable or dimension in the language of optimization algorithms. So this is Rn to R. Similarly, Gi also from Rn to R, and x is design variables. Already I have said x1 to xn. So this is a constant optimization problem. Now the traditional optimization.
Hello, sir. Your
Yes.
slides are not moving. There is just a second slide on the screen.
But here it is moving. That's I am thinking.
No. Not on any of the platform. Not on any of the desktop. It is moving. Yes, now it has moved.
Yes, now it is not in slide.
Now it is a third slide. Now it is second one.
Third. Now
Yes.
it is third.
Yes.
Okay, so its slideshow is not working. So I am doing manually. So okay,
sir.
So what is the drawbacks of traditional optimization problem? Actually, there are a lot of optimization problem like say Newtonian methods, what we have done in higher secondary by taking calculus method. Then there are some LPP methods like linear programming problem, then non-linear programming problem, then that is dual problem, etc. Then there are gradient descent problem. There are a lot of problem we have got in numerical analysis optimization problem. So, but those all traditional optimization techniques fails in some cases. First thing, if they are not continuous, this is the one major drawback. For discontinuous function, they cannot allow us. So the derivative is not possible. So that's why those traditional optimization problem generally fails to work good in such type of problems. First thing. Second thing is, if there are a lot of variables, so sometimes we have to work in major optimization problem which comes from industry. We have seen that generally they contains more than 500 variable even. So when the variables will be very huge, so then these general problems, that is traditional optimization problem, do not work good. So that is one second problem. Next is for multimodal problem. If there are a lot of optimization, that is optimal values, optimal points in a function, so in that case, there are no way out for the traditional optimization problem from the to come out from the local optima, because almost all the optimization problem has a common deficiency. They generally has a tendency to stuck in local optima. So that is the major problem when these multimodal problems are coming. So they cannot come out of the local optima. And the last and the most important problem is when the problem itself is very much complicated, or say very much non-linear. So then traditional optimization problem do not work good. Another problem is the methods, these traditional optimization problems are problem specific. For a particular type of problem, you have to use this method. For another type of problem, you have to use another method like this. So they are all problem specific optimization algorithms. But scientists are for some more universal optimization so that which can solve all type of problem. It may be unimodal, whether it might be multimodal, whether it might be very much non-linear or linear or any kind of problem, or actually discontinuous. So where we do not have gradient information, whether it is derivable or whether it has some continuity or some discontinuity, maybe finite number or infinite number of discontinuity. So for this type of problem, there was no universal method by which you can solve all type of such problems. So then drawbacks. It's coming. It's changing now.
Yes, yes,
Okay.
sir.
Okay. So there are some methods. Again, this traditional algorithm, though finally they have got some of the algorithms like dynamic uh, optimization algorithm, dynamic algorithm, then de novo programming, etc. Dynamic programming, de novo programming, which can solve multi-objective optimization problem. But they also convert first multi-objective optimization problem into a single objective optimization problem and then solve this. But there is no particular method to solve multi-objective optimization problem directly. So to solve all these kind of drawbacks which are there already for traditional optimization techniques, so the authors have gone for nature-inspired optimization techniques, though it has already at first started as single objective optimization technique. Generally, we call them global optimization technique. But subsequently, those things has been transformed into multi-objective optimization problem by using say some algorithm like you perhaps got to know NSGA2, like non-dominated sorting 2, because this is a famous paper, only Indian paper of Indian author which has got more than 25,000 citation. This is by some Dev, Kallanmoy Dev of IIT Kanpur, though right now he is in USA, Queen's University, USA. So it is the only paper of Indian author which has got more than 25,000 citations. Perhaps it is right now its citation is more than 30,000. So it is one of the paper which has that is worldwide recognition of having huge number of citations. So that what he has done, he has just changed the environment from single objective problem. Genetic algorithm is already a very popular method of optimization algorithm. So he has just changed that algorithm to multi-objective scenario. So that by genetic algorithm already there are tools of genetic algorithm. The tools are available, freely available in internet also. So you need to download those. You put your objective functions, maybe multi-objective 2 or 3 maximum we can solve by a free method. So then you may put some constant and the result will be that will automatically will give you the result. By using that tool, so many authors are publishing papers frequently in good journals. So that is one kind of problem. So if you have a very good problem, you can solve by NSGA2, non-dominated sorting genetic algorithm. So NSGA2, that is a very good method for solving multi-objective optimization problem. So this a nature-inspired optimization problem easily can solve this multi-objective optimization problems by using Pareto optimal font or Pareto font. Now nature-inspired optimization algorithms, sometimes we call them meta-heuristic. because we actually meta in, if we go in general way, meta in a is an upper level and heuristic to search. So actually we are searching, we are finding the solution by searching by an exhaustive search, and then finally we obtain the result. Now how we are searching, it is an upper level technique. So we have to use MATLAB, or you can use or if any other language you know, but in MATLAB generally we use MATLAB, and in MATLAB it is easier. But so many people apply some other programming language also. Now, two more important aspect of this nature-inspired optimization algorithm is known as exploration and exploitation. Can you please say what the time I have up to?
Sir, basically you want to finish it up to 12:10, but I think you may take time up to 12:30, 12:20.
Oh, okay, thank you.
So please try to finish in time.
Okay, thank you. So it's not possible, but I will stop when the time will be 12.
No. You explain the whole, but in brief.
Yes. Now, the main aspect of this nature-inspired optimization algorithms are exploration and exploitation. Sometimes we call exploration as a global search, and sometimes called exploitation as local search. So exploration matlab global search, and exploitation matlab local search. So, and sometimes we call them by other exploitative features and etc. Intensification, exploitation as intensification also. Now, what is exploration and exploitation? Now see, we have a problem. The dimension or number of variable of the problem is fixed. Let us take a small one, say the variable is only 3. So we have a 3-dimensional space. So let us take that the room you are sitting there, that is your search space. So in any of this point in this room may be the optimal point. So what I have to do, first thing, we need to search the entire room well. So after searching the entire room, we may find some of the points where it is possible that the optimization, that is the point of optimality, may be there. So you can find that 5 or 6 potential solutions. Now near to that potential solutions, you have to search further that whether there are some more better values or not. So the searching of the entire area, that is called exploration, and searching near an that is potential optimization solution, that is called exploitation. Now because I cannot draw here, otherwise I could have shown you. Just I am giving an example. Say there is a very big flower garden and somebody has told us to find the best flower out from that garden. So what we'll do, we'll make some part of that garden first, because it is a huge garden, so it is not possible for us to go throughout the garden for a single person. So we will make some people, we will take some people, say we'll arrange 30 people and make that part, some part. And every iteration and every time somebody, that 30, all of those 30 people will click a photograph of the flower he has got already, the best flower, and then submit here in somewhere, and we'll check which is the best one. So keep that best one and again send those 30 people again to the entire feed. So in that way, so after 100 iteration perhaps, you finally you can get which is the best flower, because there is one simple thing, already you have the best one. So in second iteration, if it is the better than the best one, you can only keep, otherwise you can discard those. So there is, so in that way, finally you have got say 5 to 6 flowers. Just you mark those points where you are getting the best flowers. Now see, since it is a flower garden and if somewhere you have got some good flower or bigger flower, so nearby that bigger flower you can have more that is better flower, or much or biggest flower nearby that bigger flower, because perhaps that soil is more fertile, or due to some reason where we have already got a good flower, we have a better chance to get the better flower there. So when we are searching the entire garden, that is called exploration. And after searching the garden, we have already got some good flower. Now we are going to search again near those good flower, whether we can get better flower near to that good flower or not. That is called exploitation. So we are first searching globally the entire field, that is exploration, and then after getting some potential solution, we are searching nearby that place to getting more better solution or the best solution. That is called exploitation. Now why it is important? Because not important. To have a very good algorithm, you need to have a very good balance between this exploration and exploitation. So if you explore more, then what will happen? You are searching the entire field throughout the day. So it will take a lot of time. So its computational cost will be very much or huge, so which may not be acceptable for the company or for anywhere for who you are working. And if you are going for exploitation more, so if you are exploiting more, so you are not searching the entire field. You have got some flower, some good flower nearby, and you are searching nearby that flower. So there is a huge chance that you are stuck in a local optima. So there should be a algorithm will be very good. The performance of an algorithm will be good only when there is a very good balance between exploration and exploitation. So every algorithm, there are more than say 350 algorithms till now, this nature inspired algorithm. So every algorithm has this part. Some part they are doing for exploration and some part they are doing exploitation. So but no, not a single method till now is completely well balanced that you can say yes, this is your ultimate solution. So every method has some problem. Now there is almost more than 350 algorithms, nature inspired algorithm, and every day there are a lot of algorithms are coming. Also what the people are doing, they are improving the existing algorithms. So there are So already there are a lot of algorithms. If you consider all those algorithms, is now more than say 2000 algorithms. Now why this much of algorithm? Why this so huge number of algorithms are flourishing? And the journals, even the very good journals, Q1 type of journals are also accepting those papers and those algorithms. Why? So this is because of no freelance theorem. So what the no freelance theorem? So by Olpert and McCarty, they have said that there cannot be one algorithm in the world, in the universe, which are suitable for every type of optimization problem. So if an algorithm is suitable for one kind of optimization problem, then it will not work good for another type of optimization problem. So there cannot be a suitable optimization problem around the world which can solve all type of optimization problem efficiently. They can solve, but those results will not be that much efficient, because whenever you will get a nature inspired optimization algorithm, when you take a nature inspired optimization algorithm, it can solve any problem, any kind of problem, whether it is linear, whether it is non-linear, whether it is discontinuous, whether it has 500 to 5000 number of that is variables. So every type of optimization problem can be solved by a nature inspired optimization algorithm, but the problem is all solution may not be that much of efficient. So that is the reason. Now this is the area, this is a roadmap if you are interested to work. So this is continuous optimization. Continuous optimization does not mean that the functions are continuous. The optimization is continuous because x can take any value, not binary or discrete. Then non-linear, because linear and quadratic are very much easy. It can within second it can find a solution by this that is nature inspired optimization problem. For linear functions, it will give you result within say a few seconds. So the problem is for non-linear. In non-linear, there are some global method or local method. We will go for global method. Then it is called meta heuristic or population based nature inspired, some improved. Now people are working in three font. One is their say giving some new algorithm, they are improving the existing algorithm, they are hybridizing two or more algorithms. So in this fonts, the people are working to solve their problems. There are a lot of, because almost all problems of industry, you can convert them into an optimization problem, except some classical design problem. Almost all problem you can convert in a optimization problem, which comes from industry. Now these are the benefits. What a heuristic I am using nature inspired automation algorithm, capital matrix. So how we'll search? They are guiding that process. So that's why we call them a upper level search process. The goal is to efficiently explore the search space in order to find near optimal solution. So meta-heuristic algorithms are approximate and usually non-deterministic. So this is one important thing. They are generally approximate, like numerical analysis, what we have seen in say higher secondary or in BSc classes. So they never gives us exact values. So why we then use? Because so many problems cannot be solved by direct methods. So we have to find some, or we have to devise some algorithms by which we can find the near optimal solutions. Now they may incorporate mechanisms to avoid getting trapped in confined areas of the search space. So already I have said that almost all optimization problem has one problem. There has a tendency to getting trapped into a local optima. So these optimization, nature inspired optimization problem has some mechanism. They can devise some mechanism, which mechanisms will give them the liberty to avoid that trapping. Now, another important why people are using meta-heuristic algorithm, because meta-heuristic algorithms are not problem specific. Just all the any kind of problem you can solve by any particular meta-heuristics. Just I need the problem and just code that problem. So and the basic coding of the method is same. You need to code only the problem and you will get your result. So these are main advantages: simplicity, flexibility, derivation-free mechanism, because we don't need derivative information, because if it is discontinuous, then we can do it. So since this for discontinuity you can do it, so we don't need derivative information. Local optima avoidance, they can devise some method that can be that algorithm can avoid local optima. And use of entire search space. So if your exploration is good, then you can use the entire search space for searching in which point or in which part your optimization, that is your global optima, is there. Okay, so if these are there are some algorithms like generally this meta-heuristic or nature-inspired algorithms are that is they are divided into four type of algorithms. One is called evolutionary algorithms. So in evolutionary algorithms, you may get some example is genetic algorithm. Genetic algorithm, it has come in 1992. Differential evolution, this is wrong. I think this is not 1992. This is perhaps in 65, near about 60, 65 or 62. Then differential evolution, it has come in 1997, and genetic programming, this has come in 1992. So this is am I audible?
Yes, sir.
Okay. So four methods or four categories we divide them. One is called evolutionary algorithm, first part. Second part is called swarm based algorithms. Third part is known as physical or chemical property based algorithms, and fourth part is known as human nature based algorithm or human based algorithm. So first part is evolutionary, which has been developed by the natural evolution, that is the principle of Darwin's principle. This is the first part of algorithm, first category of algorithm. This contains generally this genetic algorithm, differential evolution, genetic programming. Next, we'll get physical or chemical law based algorithms. So there include ray optimization. So this is in 2012. Multiverse optimization algorithm in 2016. Water evaporation, chemical reaction, atom search, mine blast. There are a few algorithms which are physical or chemical law based. Next. Next, this is here. This is here swarm intelligence algorithm. So this swarm intelligence algorithm, there is particle swarm optimization, river formation dynamics, ant colony optimization, artificial bee colony, bacterial foraging, cuckoo search, firefly. So any animal or any insect or fish or anything, if you can study the behavior of those particular insect or animal, or animal matlab it may be marine or as well as land animal, so that you can devise your optimization algorithm, because we know that nature is already nature works in optimized way. So those algorithms, those insects always works in an optimized way. So that's why by using those we can make some algorithms which works. Say you see particle sum optimization. This is one of the most important optimization. So if you tell me, if you know the four most optimization algorithm, most important one is genetic algorithm, second is particle sum optimization algorithm, third is ant colony optimization algorithm, fourth is differential evolution optimization algorithm. So if you see the industrial application of these algorithms, almost 80% industrial applications, that is industrial problem, use these four algorithms. So these four algorithms are that is it's land breaking or these are path breaking works. So they are using, and by just supporting or by just mimicking those algorithms, everyone is now putting their own algorithms. So these are, and another is human based algorithm. In human based algorithm you will find harmony search algorithm, like how musics are developed, mimicking that thing. Next, another is teaching learning based algorithm. This is also a very popular algorithm, teaching learning based algorithm. Then Jaya algorithm, then social impact based algorithm. Just I forgot the exact name. Social impact based algorithm, like this, how in a society the child are uh, just evolving. So mimicking that, some algorithms are there. So these are four different type of algorithms. So now, do I have time? So I think I should stop here.
Sir, you may take 10 more minutes.
Okay. So I just want to show you one algorithm. So one of the most important algorithm is particle swarm optimization algorithm. I'm just giving a glimpse of this particle swarm optimization algorithm. So this is particle swarm optimization algorithm. How it is, PSO was first described in 1995 by James Kennedy and Russell Eberhard. Now derived from two concepts. One is the observation of swarming habits of animals such as birds or fish. How birds or fish search their food. By mimicking this thing, they have got the one optimization algorithm, and this is one of the most important and most used optimization algorithm till now. So how birds search their food. Next, this is the concept. Now see, The PSU algorithm maintains multiple potential solutions at one time, because we need to take a first we need to take some search agent. I have already said that when we are searching some good flower, we are taking 30% who will go for search. So since 30% are going together, so we'll get 30 solutions at one time. So in that way, the PSU algorithm maintains multiple potential solutions at one time. During each iteration of the algorithm, each solution is evaluated by an objective function to determine its fitness. Since this is optimization algorithm, so first we need to have a objective function. So except objective function, without objective function, it is not possible to devise any optimization algorithms. Now each solution is represented by a particle. So what we are doing here, how that person, what I was telling in case of flower garden. So I am just giving 30%. We are allotting 30% to search the flowers, but here we will allot 30 birds or 50 birds. That means a swarm of birds. That's why it is called particle swarm optimization. A swarm of bird to search their foods. So those every position of every bird will be a particle. So and every bird, its position will be a solution for us. So each solution is represented by a particle in the fitness landscape. Matlab search space. The particles fly or swarm through the search space to find the maximum value returned by the objective function. So ultimately maximum value in case of maximization problem, if your problem is minimization, you can take minimum value. Now see how this is very interested. This is what we need to maintain, what we need to find: position in the search space, then velocity. We need to find velocity. We need to find individual best position, because say if we allow 30 birds, for that 30 birds, for every iteration we have a position. Since we have a position, we can find the fitness value, that means objective function value. So we can find what is its best position till now. Matlab say if 30% has gone for and they have bought 20 flowers, everyone bought 20 flowers. So I can say that out of those 20 flowers, which is its best flower. So that is known as individual best, and another is global best. Matlab all of that flowers, which flower is best till now, that is known as global best. So we need to know position, we need to know velocity, we need to know best position, individual best position, we need to know global best position. But how we need to know? Just let us come. There is a simple equation. Now this is the equation. This is the equation of the velocity. Vit plus 1, t plus 1 means iteration number, t plus 1th iteration. Now there is a w into Vit, so its previous velocity. So initially we will consider in first iteration, we will consider that its velocity is 0. So then velocity will increase in subsequent iteration. So in t plus 1th iteration, we are considering tth iteration, velocity of tth iteration, plus c1 into r1 into xi cap t minus xi t. Now what is c1? C1 is called acceleration coefficient, and its value generally lies between 0 and 2. R1 is a random number taken between 0 and 1. Xit is ith bird's best position till now, that is local best, minus xit, its position in ith iteration, plus c2 r2. C2 means c2 is acceleration coefficient between 0 and 2. R2 is a random number between 0 and 1. GT means the best position till now, the whole swarms, not ith. This one best position of till now for ith particle, but GT is best position till now for the whole swarm. Minus xit means the position of the bird or position of the particle in ith iteration. So this is only equation. So it is very simple. You can code it only by say in MATLAB with say 10 to 12 lines of code, you can complete it. Now this is our velocity update. So everything, see, everything we know. W is called initial coefficient, and generally it is taken, it has been taken between 0.8 to 1.2. and C1 is a coefficient, acceleration coefficient taken between 0 and 2, generally 1.8, 1.2 to 1.8. R1 is a random number between 0 and 1, so you can easily take random number. XIT is the ith bird's best position till now. XIT is ith bird's position in that iteration. C2 again acceleration coefficient lying between 0 and 2. R2 is a random number between 0 and 1. GT is the position of the best bird in the swarm, and XIT is again the position of the ith bird in that particular iteration. So this is only equation, and next your value position. This is position update. So position in t plus 1 iteration is its previous position plus its velocity. Only this is the formulation of particle sum optimization. So by using this formulation, there are thousands of problems that can.
Requesting again and again to mute your mics, please.
So this is an actually I have I can send it for you. There is an example. If you want to see it, I need at least 30 minutes to explain it. So I don't think I will get this time. I may send it to the organizers so that they can distribute if you want. So any questions, please?
Thank you, Professor Saha.
Thank you, ma'am.
I do not get any question in the chat box. It simply means that your talk is so explanatory or so interesting that they are still in the mood to find their new ways in through your talk.
Yes, and anyone from any branch can work in this topic.
Yeah,
because when I search literature, I find very few people which is from mathematical background who are working in this. Maximum engineers works, even some physics people I have got, they are also working, and mathematics people, a lot of mathematics people are also working in this field. So if anyone is interested, it is not necessary that they need to have a very much stronger mathematical background. So without having very much stronger mathematical background, they can work on this field. This is the beauty of this field.
But I have a request with Professor Saha that we would like that you deliver a lecture in our department to show, to tell us or to explain us that how the movement of a coral reef or a bee or a butterfly can inspire us to create an algo. As you are saying.
Yes. So, whatever you have said, coral that has a optimization algorithm by hand. So every there are a lot of optimization. I'm sure. If sometimes I find any occasion, I'll come to you and I'll explain everything.
Sure. So thank you so much, sir. You talked about the drawbacks of traditional optimization problems, and as I think that optimization technique is related to the problems which are related to our practical life. And when nature is connected with it, it becomes multiply connected with the real life. So it becomes very interesting. You talked about that when we handle any problem by the traditional optimization problem, there are certain limitations or constants, like if there are more number of constants, then there is a problem. If our function is discontinuous, then there is a problem. If variables are big in number, then there is a problem. And naturally, when we want to reach or explore a real problem, we have to consider lot number of variables. If we consider a small number of variables, then naturally we are making approximations.
Because this optimization algorithms even used to find the optimal trajectory for the spacecraft. So you can think when a spacecraft will move, how many variable and how many constants will be there. So it's a huge problem.
Yes. So your talk is very interesting because your algos are related to the movement of the living being existing in the nature. So this is very interesting part. Even I have heard it very first time. So I'm sure that your talk is very much beneficiary for many of us. And naturally, it has shaken our mind to think about it, that whenever we go to some natural place, then to see the movement of those living beings present
Yes, yes,
there, and then to think about the algo which may be developed according to their movement.
yes.
So your talk is very interesting, sir. So I thank you very much. And for the formal thanks, I hand over the platform to the Harshita.
Thank you, madam.
Thank you, sir. Thank you, ma'am. On behalf of the organizing committee, I, Harshita Shishodia, student of MSc, CCSU campus itself. My sincere thanks to you, sir, Dr. Apu Kumar Saha, sir, who gave his busiest time for grossing the event and gave his precious time to our institute and provided us very beneficial and informative knowledge on the topic application of MATLAB and Python. So your knowledge has opened our minds and shown us a new path in the respective field. I also thanks to Dr. Jamala ma'am for chairing the session. I'm also obliged to all the learned persons and students for attending the session. I'm thankful to the person and for managing the technicalities of the session beautifully. Last but not the least, I would like to thank the organizing committee for giving me this opportunity to be the part of this session. Thank you, sir. Thank you, ma'am.
Thank you.
Thank you.
So now I request the second speaker of this session, Dr. Pitam Singh. So whether he will confirm that he has joined the session or not. I would like to mention, Professor Saha, that some of the people came in between your talk, that please provide him more time because his talk is very interesting.
Okay, okay. Sorry for that. So that I am taking much time. So now
So
another.
we'll surely call you again in our department.
Okay,
And
sure, sure.
we will try to call you physically in our department.
Yes, yes, yes. That is important for interaction.
Yeah.
That is important. Actually.
Yes, yes, yes.
Mukesh sir, thank you.
So now I would introduce our second speaker.
So, madam, for your permission, with your permissions, can I leave, because actually NBA team are visiting my campus. So we
Sure,
are
sir,
super
sure,
busy.
sure. Sure,
Thank
sir,
you.
sure. Thank you. Thank you so much.
Thank you, Dr. Saha.
Thank you, sir.
So now I am feeling very much pleasure to introduce my next resource person of this session. I think the voice is echoing. Hello, am I audible?
Join मत करना.
Am I audible?
Yes,
Dr.
ma'am.
Mukesh, please confirm. Yes, okay. So it is a matter of pleasure for me to introduce the next resource person. And the reason being that the next resource person was one of my student in this department. I can see a broad smile on his face, because when you introduce your student as a resource person, it is a matter of pride for a teacher. And I can claim that Dr. Pitam Singh was one of the best students who did a lot of hard work to complete his MPhil project in my supervision. And naturally, when he has shifted his field, again, he did a lot of hard work to enter into the field of fuzzy. So we welcome you, Dr. Pitam Singh. Now, as a resource person, I know that in my usual routine, I call him Pitam. And now, as he's a resource person, so I'm calling him Dr. Pitam Singh. And you will talk about fuzzy AHP. I do not know what is AHP, so I would be very much interested in listening your talk. So you will talk about fuzzy AHP, and before handling you to this platform, I would like to introduce you, as the initial part of your introduction has already been provided by me. You were basically the student of this department, and even presently you are always ready to help our students, and many of our students who did either MSc or MPhil from this department have completed or are completing their research under Dr. Pitam Singh. He's always helpful for this department. His area of research is fuzzy optimization and applications in GIS and remote sensing, mathematical modeling in seismology. In 2014, he has been honored by United Group of Institutions in EduShine 2014 for his contribution to academic field and social world. He's a member of so many academic and professional bodies. He has completed 2 research projects, one by DST SCRB, Government of India, and that project was based on sum of fractional multi-objective programming problems. And another project which he got from PSSR MHRD was on the topic social priority based urban road transport system using GIS and DEA, performance assessment and designing for major cities of Uttar Pradesh. So as I can understand, both the projects are very much related to some of the problems existing in the real world. 4 PhDs have been completed under his supervision. Currently, 4 research scholars are doing research in his guidance. And he has authored or co-authored more than 40 research papers in the highly reputed journals. So now I invite you, Dr. Pitam Singh, to start your talk or conversation on fuzzy AHP. So platform to Dr. Pitam Singh.
Oh, thank you, madam. Am I audible?
Yes, yes.
Thank you very much, and thank you, Professor Sharma and my senior colleagues. And it is a matter of pleasure to me. So today I'm going to give some kind of tutorials how to apply the fuzzy, what is fuzzy AHP, and how to apply it in the real problems. So it is the part of multi-criteria decision analysis. So what is multi-criteria decision analysis? Is a formal, structured and transparent decision-making methodology. It assists a group or individual decision makers to explore their decisions in case of complex situation with multi-criteria. So multi-criteria decision analysis does not provide the right answer, but it gives the some selection process, some criteria. So we have some basic terms in multi-criteria decision analysis. Decision, it means, as we know, decision is a choice between alternatives. So in a real world, we have various alternatives. So it is a method how to select the best one on the basis of our decided criteria. So what is the criteria? Criteria is some basis for a decision that can be measured and evaluated. So it is the evidence upon which a decision is based. We have some factors, we have some constants. So we have 2 kinds of situations. We have some factors as a criteria. We have some constants for that factor. So factor is a criteria that enhance the suitability of the specific alternatives for the activity under consideration. What is the constants? Constants serves to limit the alternatives under consideration.
Excuse me. Perhaps some mic is on. Please off your mic.
In many cases, the constants will express in the form of Boolean maps. Sometimes we have area being excluded from the consideration and coded at 0, 1, those open, and for closed, and 0, 0 or 1 in a binary way. But in fuzzy sense, we take it as in a between them. So we have some certain steps in multi-carrier decision analysis. First step is the decision maker first has to set some goals or define a problem, and the decision maker has to decide some criteria or factors and standardize the factors, criteria, scores, determine the weight of the each factors, and then aggregate all these things, then verify the results, then we have the select the best one alternatives. So we have some characteristics of the criteria, the completeness, redundancy, operationality. It has to satisfy all these things, or mutual independence of the criteria, or number of criteria, how many criteria you are considering for selecting any of the alternatives. So we are taking here the three types of analytic hierarchy process. In the classical hierarchy process, it means that is AHP, fuzzy AHP based on. So we have many multi-carrier decision analysis. These are listed here. So because of time, I am not considering all these things. So I'm focusing on the AHP and fuzzy AHP only. So what is analytic hierarchy process? So the analytic hierarchy process was introduced by Sati in 1977 and is a very popular means to calculate the needed weighting factors with the help of pairwise comparison matrix. So we should compare the criteria. We should compare the all weighted criteria. So AHP provides a calculable consistency factor that provides a decision maker with a considerably higher level of confidence in the criteria weighting process. This is the main basic algorithm for AHP. So first we have the decision maker has to select the criteria, construct the pairwise comparison matrix. He has to calculate the weights, consistency ratio. It gives the testing whether the weights are taking in a right way or not. Criteria preference are taking in a right way. CR, if CR consistency ratio less than 10% threshold, so it is given by Sati, the threshold, then it means the output is we have taken the right, we have selecting right priority. If it is not, so we have to change the criteria priority, then we solve it. So analytic hierarchy process. So what is how to make the pairwise comparison matrix? So pairwise comparison matrix is constructed by assigning relative importance. In a real situation, selecting any alternatives, we have some preferences over there. So so these are the routine practice to that we give one. If we have 10 and more than 5 criteria or 10 criteria, so we can, if we have equal importance to each one, so we give intensity of the importance is 1, moderate importance between them, so we give 3, rank, stronger essentially importance with, between all the criteria or any one, 5, a very strong importance is 7, or extremely importance criteria is 9. So or we can take intermediate values between them 2, 4, 6, 8, or for inversely we take inverse of these values of inverse comparison between them. So so we have to make this comparison matrix between the criteria. So it is the pairwise comparison rating for kth and pth criteria and n number of criteria. So first, the entries in the C are normalized. We normalize the entries. Weights are calculating by using that summation p equal to 1 to n ckp upon n, and the consistency ratio CR formula is this, where lambda x is the greatest eigenvalue of the preference matrix and Ri is the random index. So it comes through the random numbers. So we take this. So CR is less than 0.10. Then we say it means we have calculated the right criteria. We are doing the best one. So how to create so step 1, how to create the comparison matrix. So we, for example, suppose we are treating a trot suitability model. So for fish living things, or so we assume we use one is temperature. Temperature should be there. Water quality is needed to suitability of trot, and stream structure. So we should have some flow in our water. So we have these 3 criteria: temperature, water quality, and stream structure. So this is pairwise comparison matrix for these 3 criteria. So get comparison. So decision maker has to decide for 1 for equal preference, 3 for preferred, and 6 for strongly preferred. So this is the ranking criteria to make this matrix, and we are selecting according to these criteria, these preferences. So we have to to finding the suitable trot sites, we decide that temperature is preferred over water quality. It means temperature is much needed than water quality. So then temperature is strongly preferred over stream structure, and water quality is preferred over the stream structure. So this is the way criteria preference according to we are selecting the trot suitability site. So after making this, we can see that temperature this. So we are for equal importance. It means temperature to temperature is same. Water quality to water quality is 1, and stream structure to stream structure is 1, because this is so temperature here, the temperature water quality, temperature is preferred according to that. So we are given 3 here. So we can, if we take water quality X, temperature is 3 times better, preferred. According to that, the preferred. So 3 times. So we have 3x upon x. The ratio, it means 3. Similarly, these are reciprocals of this. So we can fill this matrix according to water quality with temperature this. So 1 by 3 according to this. So this is the inverse structure, inversely. So this is the after filling the reciprocal values. So this is the pairwise comparison matrix given by Sati. So to calculate the weight of the criteria, weight of the criteria for evaluation of this matrix. So we have sum of columns, some of these the column wise. So we have 1.5, 4.33, and 10.5. 0, 0. So after normalizing this matrix, we have normalized the matrix that after multiplying this sum divided by 1.5, this one. So we have the normalized matrix, this. Okay. So normalized matrix. So find the average of each row of this matrix. So this will be the weight of the criteria. Temperature weight, water quality weights, structural weight. So weight of the criteria are for the temperature is this. So under the total sum, automatically this is the percentage type. This is equal to 1. So check for now we have to. So we have to test the consistency in a comparison matrix. First, computing the consistency vector. So we have the weights of the. This is our matrix, comparison matrix, normal matrix. So temperature, after multiplying these weights, we get this, and temperature divided by sum of this 1.9, 0.56 divided by 3, 3.2, 2. So we have new consistency vector. Now that we have consistency vector, we need to compute 2 more terms, that is lambda and consistency index. So lambda is the average of consistency vector in a step 5. So lambda equal to average of this. So it is 3.10 in this particular example. So to compute the consistency index, which provides a measure from consistency, Ci lambda minus n upon n minus 1. This is the formula for consistency. So n is here the number of criteria. So Ci is here 0.050. So with this consistency index, we can now use the random index. So we have total number of criteria here is 3. So random Ri is here 0.58. So it is random table. So with the consistency index, we can now use the random index table to compute this. So 0.050 upon this. So it is 0.086. So it is less than 10%. It means we have calculated, we have selected the best one. So 0. This. So that this is all about the how to work the AHP in a crisp data. But in a fuzzy set theory, in multi-criteria decision making process, so it is as already discussed in the first lecture. So fuzzy set theory given by Zadeh in 1965, and after that it is used in multi-criteria decision making with the help of AHP in Berkeley 1984 and Chang 1996. So fuzzy AHP discovered by Berkeley with the in the using a geometric mean process. Chang with the Chang 1996 as with the help of possibility theory, or you can say fuzzy extent analysis. So the conventional, as I told, the conventional AHP is Sati 1980, 1970, 19. So it is imprecise and linguistic assessment. Or so we have. So I'm discussing here 2 methods in a fuzzy AHP. One is fuzzy geometric mean method, and second one is given by Chang in fuzzy extent analysis method. So fuzzy geometric mean method. So we have the common steps like classical AHP in the fuzzy set theory. The fuzzy AHP, just we have the data. The entries are fuzzy numbers. So in the first step, fuzzy pairwise comparison matrix were formed using all the parameters in the dimension of the hierarchy system. So that Cij, so it is the triangular, we are taking the parameter here, the triangular fuzzy numbers. So make the comparison matrix like that, this. So calculate the fuzzy geometric mean, fuzzy weights for each criteria as this fuzzy geometric mean. The formula is for each AI, I1, AI2, AI3, AIN power 1 by n. And fuzzy weights are calculated by Ri, geometric mean multiplied.
May I request Dr. Pitam Singh to please conclude it within 10 minutes, please.
So that
You may skip the mathematical part or whatever you want.
Okay. So geometric, so we can make the comparison matrix like that. Already we know the fuzzy mathematics equally important. So we take one. So this is these are linguistic variables in the fuzzy sense. Equally important, weakly more important, strongly more important, strongly. So these are the reciprocals of these, and these are the how to we can take another fuzzy numbers according to the geometrical fuzzy geometric mean methods. The mathematic, suppose so I explain this through one example. Suppose in the university selection process, a university, the post of professor is vacant and 3 candidates A1, A2, A applied for the post, and the committee has to select best candidate on the basis of these 4 criteria: mathematical creativity, implementations, how to experiment his mathematical, how to implementation, it means experimental ability, administrative quality, and human maturity, personality, or their communication skills on the basis of that. And we are preferring selecting the candidate C4. It means that human values should be more important than the mathematical creativity. So the administration decided to these criteria for the selection before the selection process. So we have C1, C2, 4 criteria, and we make the comparison matrix for that. And these are the calculation of geometric mean. With the help of this, we have, and the weights are calculated like that. So W1, W2, fuzzy weights are calculated using equation 7. So these are the weights. So now the fuzzified the weights in a defuzzified using the central. So we can defuzzify these weights in a classical, because the user needs a solution in the classical sense. So defuzzified the weight, then normalize the weights, and from the above conclusion, the highest preference is obtained weights for the 36% for C4. So we have we are appointing the professor on the basis of our preferred criteria is C4 according to that weight. Similarly, another method is fuzzy extent analysis method. The fuzzy extent analysis with the same the process, we have to make the comparison matrix to construct the fuzzified pairwise comparison matrix. in n parameters like that. This is the formula to compute the fuzzy synthetic extent with respect to the ith parameter using the method given by Cheng, Si equal to summation. So we have to find that this through in case of fuzzy numbers, we can find sum of this, sum of lower, upper, and middle. Similarly, sum of this to compute the degree of possibility of two fuzzy numbers, say S2, S1, or fuzzy priority L1, S1 and S2. So we use this degree of possibility V H2 greater than S1 with the help of this formula. 1 if middle greater than M1, 0 if lower one greater than lower 2 in a fuzzy number, two fuzzy numbers. So this is the comparison between the two fuzzy numbers, and otherwise we can use this formula. So to compute the degree of possibility of V for fuzzy number is to be greater than the k fuzzy numbers mk. So we sk, it is sk here. So vsi s1 s2 sk, so minimum of these two. So we apply or then compute the weight factor. Let us assume that it is a weight factor with respect to each element under the certain parameter of criteria. It is represented by this minimum of all these. So we apply for this with the same example here. So we can take the criteria C1, C2, C3, C4, C1, C2, C3 for criteria explained in the previous method. So we can find the SI. It means S1 is can be find this by inverting this sum of this. So we have S1, S2, S3, S4 vectors. Degree of possibility is calculated using this 13. So VS1 greater than S2. So it is, these are the VS1 greater than S2, S3, S4, S4 like that. So for fuzzy extent and the similarly all the values are calculated with the help of this method. So to compute the degree of possibility V for a convex in fuzzy number, so it is greater than the kth convex fuzzy numbers. So DC1, S1, S2, it is the minimum of all these for S1, S2, S3. For S1, so this is 0.32, this is 0.4, or for this is 1. So to compute the weight criteria, so it is this vector. So 0.32, 0.9, 0.6, 4. So normalize this weight vector. It is 0.13, 0.41, 0.03. So in a fuzzy synthetic excellence analysis, the highest priority is obtained 43% in this method. So the criteria for is the weight of the weights for criteria 4 is greater than the others. So we have our second level decision process. Suppose second level, we can also do how to select the candidate. So the expert, so for we have to evaluate the candidate, each candidate on the basis of our decided criteria C1, C2, C3. For C1, this is the pairwise comparison matrix. This is C2 for pairwise comparison matrix. C3, it is a pairwise comparison matrix. So for each candidate, so we have to find the weights of the each candidate on the basis of each criteria C1, C2, C3, C4. So with the help of extent analysis, we found the weight for A1, C1 is 0.2 like that. So this is the weights of the each candidate under the criteria. For this is for A1, this is A2, this is for A3. These are three candidates. So finally, adding the weight of the each candidate, this 0.41 candidate and multiply by the weights of the corresponding criteria. So we have already evaluated ourselves on the basis of criteria what we are going to give the priority to the candidate. So this is the weight of the candidates on the basis of criteria, and previous one was the select weights of the criteria. So multiply them, some of these, and so we have final score of the candidate, and the based on the final score, it is clear that the A1 candidate is preferred to A2, A3. So this is how to select. So, and me and my team applied these techniques in the field of GIS and remote sensing with the help of satellite imagery. How can we identify the suitable sites for groundwater potentiality, or how to select on the basis of, so with the help of, so we applied this how to select, and another one applications we have applied, you can Google it, the alignment selection. When any construction company or road construction company construct the, so before that he had to the company has to survey what is the alignment in the land. So we have the company has to create various alignment and select best one on the basis of environmental clearance, or the slope criteria, the soil criteria, what type of soil is there. So it is the part of civil engineering. So me and my student did some work in this field also to apply this. So that is this was our how to apply, how to calculate weight of the criteria, and how to select the best alternatives. Also, thank you. If you have any question, if you
Thank you
have
so
any
much, Dr.
questions.
Pitam Singh. I think there is no question in the chat box. Actually, both the talks were so explanatory that I don't think that there is any question left with the participants. So you talked about multi-criteria decision analysis, right? MCDA. I'll take a minute, please. Sorry. So now I can also understand what is this AHP, analytic hierarchy process. Right. So in this you told about the architecture of analytic hierarchy process.
Yes.
Just a minute.
Student.
Yeah. In this you talk about that we should select criteria, then construct pairwise comparison matrix, then calculate weight, then calculate constancy ratio, and then naturally if and but. If it is so, then do this. If this is so, then do this. Either yes or no. So you put all these things very beautifully and very fruitfully. And the main thing is that you have explained the mathematical process of an example. And I'm sure that the participants have taken a lot of benefit from your talk, and we would be happy the department. I know that you're always ready to be connected with your native place. This is your native place. And thank you so much, Professor Pitam Singh, Dr. Pitam Singh, for your talk. And now I invite of our student for the formal thanks.
Good afternoon, all. On behalf of the organizing committee of this seminar, I would like to thank you, sir, from the bottom of my heart for taking time for your busy schedule to be the guest speaker. Your presence and wise words
help magnifying our seminar in the best possible way. All thanks to your enlightening words that inspired so many people present here. I thank you for gracing our seminar in roasting all our spirit. I also thank Dr. Jamala ma'am for chairing this session, and I'm also obliged to all the learner person and students for attending this session. I'm thankful to the person for managing the technicalities of this session beautifully. Last but not least, I would like to thank the organizing committee for giving me this opportunity to be the part of this seminar. Thank you, sir. Thank you, ma'am.
Thank you so much.
Now
Thank
we
you, sir.
will start our next session, which will be in the offline mode. So whoever are presented here in the department are requested to come for this technical session, for which the venue is in the Department of Mathematics. So all of us are moving to that for that session. Thank you so much. Thank you all.
Sir, yes.
हाँ पीपीटी खोल देंगे पता नहीं सर कहाँ पर डालेंगे मैं खोल दूँ डाल के डेस्कटॉप पर ओपन कर दो डेस्कटॉप पर ये डालो खोल लो कर दूँगी ये वो तो बात नहीं जी सर जी सर जी सर ये फुल हो जाएगी सर ठीक
Okay, you have 10 minutes for your presentation.
Good afternoon, everyone. I'm Sani Gupta from DN College Meerut. Here I am presenting my presentation on Diophantine equation. And these are the content of my presentation. The title of my presentation is on Pell equation u raised to the power 2 minus p v raised to the power 2 is equal to -1 for all prime between 1 and 100, where p is prime and u and v both are positive integer. And abstract is for the prime p and positive integer u and v, we consider Pell equation u square minus p v square is equal to -1. We discuss the solubility of the Diophantine equation D for every prime between 1 and 100. And the keywords of this paper is Diophantine equation, Pell equation, and continued fraction expansion. And these are the introduction. These are some abbreviation of my paper. and the preliminary continued fraction. सर पढ़ के बता दूं ठीक है. Let a1 be an arbitrary integer and a2 a3 up to an be positive integer, then these expression is called a continued fraction. It is also written as a1 a2 up to an is equal to a1 plus 1 upon a2 plus 1 upon a3 and so on, where a1 is called first partial quotient and a2 is called second partial quotient, and similarly an is called nth partial quotient. And penultimate convergent, let x is equal to a1 a2 a3 up to an, and let n belongs to 0 to n, then a1 a1 a2 a1 a2 a3 and so on are called the first, second, third and nth convergent respectively to the continued fraction. Let Cn greater than or equal to 0 be a sequence of nth convergent of continued function expansion a1 a2 a3 up to an of x. Cn is a fraction which of the form Pn upon Qn, where Pn and Qn both are integer and Qn is not equal to 0. In a continued fraction, the first convergent is P1 upon Q1 and second convergent is P2 upon Q2, which is equal to a1 into a2 plus 1 upon a2. Let n greater than and equal to 2, then the nth convergent Pn upon Qn of a continued fraction is given by the formulating Pn is equal to an into Pn minus 1 plus Pn minus 2, and Qn is equal to an into Qn minus 1 plus Qn minus 2, where P1 is equal to a1 and P2 is equal to a1 into a2 plus 1, Q1 is equal to 1 and Q2 is equal to a2. ये बड़ा कम है यहाँ से इस वाले. These are the some theorem we use in my paper. The theorem 3.1 say let r greater than 0, then x naught comma y naught is equal to 0 comma 1 is a trivial solution of Pell equation. And the theorem 3.2 say let r greater than 0, then the Pell equation x square minus ry square is equal to 1 has infinite integral. And these are the main theorem, Pell equation, and we arise 9 cases in this theorem. First case, if p is equal to 2, then my fundamental solution is 1, 2, and other solution can be obtained by the relation xr plus yr under root 3 is equal to 1 plus under root 3 raised to the power r, where r is equal to 1, 2, 3 and so on. And this is the second case if prime p is 5. And this is the third case if prime p is 17. Similarly, these are the fourth case if choice of prime p is 29. And case fifth if choice of prime p is 41. Case 6 if choice of prime p is 53. Case 7 if choice of prime p is 61. Case 7 if choice of prime p is 73. And case 9 if choice of prime p is 97. And in all cases, some table are given. This is a table of solution table for choice of prime p. Prime p 2, 5, 17, 29, 41, 53, 61, 73 and 97. And this table contains fundamental solution and some other solution. Here we given also another table which have no solution for prime 3, 7, 11, 13, 19, 23, 31, 37, 43, 47, 59, 67, 71, 79, 83, and 89. For all these prime, this PAL equation have no integer solution. The conclusion of this paper is the PAL equation is solvable only for prime P if P is possible 2, 5, 17, 29, 41, 53, 61, 73, and 97 between 1 and 100. And other all prime between 1 and 100, these equations have no solution. And these are the reference of this paper. Thank you. सर अभी नहीं हुआ, अभी चल रहा है सर, प्रोसीडिंग में ही वाला भी। सर इसमें मैंने 100 तक सारे पोस्ट जितने प्राइम थे उन पे सब पे काम करके देखा था, तो अभी इसमें सर और चेक करें, एक जनरल फॉर्म भी बनाई जा सकती है सर इसकी, जिसे मैनुअली किया अभी उसमें सर, जैसे कि अभी कुछ प्राइम है तो उनकी सीक्वेंस फॉर्म, मतलब हर प्राइम तो नहीं आ सकता सर उसमें, अगर किसी सीक्वेंस से कुछ प्राइम जनरेट हो, जैसे मैंने एक पेपर और बनाया था सर इस पे, उसमें कुछ पॉलिनोमियल इक्वेशन ली थी सर मैंने उसमें। जी सर, सर वो तो मैनुअली ही देखना पड़ेगा वो भी। सर वो तो रिसर्च करके देखना पड़ेगा, कुछ ऐसा पॉसिबल कुछ बन पाया तो, क्योंकि पॉसिबल तो सर सब चीजें होती। हाँ सर वही तो कह रहा हूँ सर, कुछ सर मैंने पॉलिनोमियल पे तो बनाया है सर इसी तरह का पेपर, जो एक पॉलिनोमियल इक्वेशन ली और उस पे जो भी टी की वैल्यू हम जितनी वैरी करते जाएंगे, जितनी भी वैल्यू आएंगे सबके लिए सॉल्यूशन वो देगा, तो उसमें सर मैंने एक बनाया है ऑलरेडी एक और। नहीं सर जी।